Hi everyone, lecture 3 of 4, subtopic 5.2 composite functions, learning outcomes. At the end of the lesson, students should be able to represent a composite function using an arrow diagram, find the composite function, find one of the functions when the composite and the other functions are given. Composite functions. Composite functions are functions that arise as a result of the combination of two or more basic functions. For example, the functions f x mapped to y and g y mapped to z can be composed to yield a function which maps x in x to g of x in z. The resulting composite function is denoted as g of f, defined by g of fx is equal to g of x. Example 17. Given that elements of set A, B and C are defined as follows. So we have three different sets which are A, B and C. I'm going to write down all the elements in A, B and C. The function f is A mapped to B. So A mapped to B is function f, and B mapped to C is function G. First of all, I'm going to substitute the elements of A in f to get the values in B. So for the first one, we have A, the first element in A is negative 3. So I'm going to substitute negative 3 into the function f. So we have set negative 3 plus 1, which is set negative 2. And set negative 2 does not lie in element B. So we couldn't map negative 3 to anyone in B. So next, f negative 2, we're going to have set negative 2 plus 1, which is set negative 1. No values of set negative 1 in B, so proceed with the next value, which is negative 1. So we have negative 1 plus 1, set 0, which is 0. So since we have 0, since 0 is one of the elements in B, so we could map negative 1 to 0. Next, f3, substitute into f. So we have set 4, which is 2. So we could map 3 to 2. And for the last one, f8 is equal to set 8 plus 1, set 9, which is equal to 3. So we can map 8 to 3. We're going to repeat the same process, but I'm going to substitute the values in B into the function G. So for the first value of B, which is 0, so we're going to have G0 is equal to 0 square, 0. So we can map 0 to 0. The next, 2, G2 is equal to 2 square, which is 4. So we can map 2 to 4. And then 3, G3 is equal to 3 square 9. So 3 map to 9. Map to 9. So we have the final answer for G of x, which means when we substitute f into G, so we have 0, 4, and 9. Example 18. If fx is equal to x squared, gx equal to 1 plus x, and hx equal to set x, find a f gx. Substitute g into f. So gx is 1 plus x, And then we're going to substitute 1 plus x into f. So it's going to be 1 plus x squared. Next, g fx. Write down fx first. G is x squared. And then substitute f into g. Going to be 1 plus x squared. C, f square x means f of x. Substitute f into f. So since our fx is x squared, so it's going to be x squared and then another square outside. So x to the power of 4. And for the last one, fghx, we need to substitute h into g and then into f. Write down the h first. So h is x. Substitute x into g. X into g. So we're going to have 1 plus x. And then substitute into f. Substitute into f. So 1 plus x squared. Example 19. If fx equal to 3x, gx equal to 2x minus 1, and hx equal to x squared, find a gf3. Substitute 3 into the f, which will give us the value of 9. Since 3 multiplied with 3, so we have 9. And substitute 9 into g, so we're going to have 2, 9 minus 1, which is 17. Next, b, substitute 2 into h, so we have h2 equal to 2 squared, which is 4. And then substitute 4 into g, so we're going to have 2, 4 minus 1, which is 7. And then substitute 7 into the f, so we're going to have 3 multiplied with 7, which is 21. And for the last one, GHF4. Substitute 4 into the f, so we have 3 multiplied with 4, which is 12. And then substitute 12 into the h, so we have 12 squared, 144. And then substitute 144 into g, which is 2 multiplied with 144 minus 1 is equal to 287. Example 20. The functions f, g, and h are defined by fx equal to 2 minus x, gx equal to 3 over x plus 1, and hx equal to 2x minus 1. A. Show that f square x equal to x. For A, f square x mean f of x equal to x. So since we are going to show fx equal to x, so we need to substitute f into the f. Okay, I'm going to write down fx first, which is 2 minus x, and then substitute 2 minus x into the f, and we're going to end up with x shown. B. Find an expression for g square x. So we need to find gx. I'm going to write down gx first. And then I'm going to substitute 3 over x plus 1 into g. and then simplify it. Equate denominator. Then since we have 3, divide by 4 plus x over x plus 1. Change it to multiply. Flip it. And we have 3x plus 3 over 4 plus x. That is our GGX. And the next, state for which two values of x it is undefined. So the function is going to be undefined when denominator is equal to 0. So the first value that will make our function undefined is when x plus 1 equal to 0. So x equal to -1 is one of the value, and for the other value is when 4 plus x is equal to 0. So when x equal to -4, our function is going to be undefined. Thus, the conclusion is that g square x or GGX is undefined when denominator equal to 0, which is when x equal to -1 and when x equal to -4. Last one, solve the equation h cube x equal to x. See, h cube x mean hx equal to x. Substitute h into the h. So I'm going to write down hx first, to x minus 1. And then I'm going to substitute 2x minus 1 into the h. And then simplify it. And then substitute 4x minus 3 into the h again. And then make it equal to x. And then simplify. And we get x equal to 1. Example 21. The function g is defined by gx equal to set x minus 1. Determine the function fx if g of x equal to 2 over x. We're given gx, and then we need to find the function fx if g of x equal to 2 over x. Write down the composite function first, which is g of x equal to 2 over x. And then if the unknown function is the inner function, we're just going to substitute fx into g. So here, change x to fx. So we have fx minus 1 set equal to 2 over x. If we don't know the inner function, just substitute the inner function into the outer function. And then simplify until we get fx as a subject. So move out the square root, become square. Simplify 4 over x squared. Simplify again. Fx equal to 4 over x squared plus 1. That is the if f gx equal to 4x squared minus 2x plus 1 and gx equal to 2x plus 1, find the function of fx. We're given composite function and gx. We need to find fx. Fx is the outer function. So we're going to start with composite function first. f gx equal to 4x squared minus 2x plus 1. And then substitute gx, which is 2x plus 1. Right. For this question, we don't know the outer function. When the outer function is unknown, we're going to use let in order to find the outer function. So I'm going to let 2x plus 1 equal to u, for example, and then rearrange until I get x as a subject. Here I'm going to change all the x in terms of u. So we have fu, since we already let 2x plus 1 equal to u, so fu equal to 4, and then change x in terms of u. Change x in terms of u. Here we go, and then just simplify. Open up the bracket. Cancel out. Cancel out again. So we have u squared minus 2u plus 1 minus u plus 1 plus 1. So fu is equal to u squared minus 3u plus 3. Lastly, change u to x. So we have fx equal to x squared minus 3x plus 3.